Some denominators can't be rationalized by just multiplying the top and bottom by a simple square root or cube root or something. For example, in this one, we see that root 7 in the denominator, but multiplying the top and bottom by root 7 won't really accomplish anything. Because of the distributive property, we would have to multiply the root 7 times both pieces, and so although root 7 times root 7 would equal 7, root 7 times that negative 2 would equal negative 2 root 7. Or in other words, we would have accomplished nothing. We would still have a square root in the denominator. So that's where conjugate pairs come in. So what we're going to do is we're going to multiply the top and bottom by what's called the conjugate pair of that expression in the denominator. And so I'm going to keep both pieces the same, root 7 and 2. I'm just going to change the positive or negative sign in between them to make it so that when I multiply, I'll end up with a FOIL difference of squares type pattern, which will then cause the outer and inner terms to disappear, and therefore will give me a pathway to eliminating the square root symbol. So if I put those in parentheses, I do need to multiply the top by that exact same thing as well. But if I focus on the bottom for now, root 7 times root 7 is going to give me 7. And then my outer term is going to be 2 times root 7. My inner term is going to be negative 2 times root 7. So hopefully we can see that those are going to cancel each other out. And so then my last term is negative 2 times positive 2, which is negative 4. And so you can see that the terms all are rational. They all are integer values in the denominator, so I no longer have a square root in the denominator. In the top, I'm going to leave it for now as 12 times root 7 plus 2 in parentheses. I'll have some distributive property to do in a minute, but I'll leave that there for now. Now on the bottom, 7 minus 4 is 3, so we have 12 still times root 7 plus 2 all over 3. And so now I'm going to check to see if I can simplify. This is why I didn't distribute earlier, because now I've got this 12 and this 3 that I can simplify. The 3 goes, the 12 becomes a 4, and so we have 4 times the square root of 7 plus 2. And so now I'm going to go ahead and distribute it to make 4 root 7 plus 8. So here's an example of how we can rationalize the denominator when it's got some addition or subtraction involved. In the second example, we're going to do the same sort of thing. Multiplying by just root 5 or just root 3 isn't going to accomplish anything. Instead, I'm going to use that conjugate pair. So the root 5 is going to stay the same, the root 3 is going to stay the same. I'm just going to change the positive negative sign in between to minus from plus. And so I have to multiply by the same thing on both the top and the bottom, otherwise I'm changing the value of the expression. But now we're ready to go. So on the bottom, if I put those in parentheses everywhere, I've got root 5 times root 5 is just 5. Just like on the previous example, those outer and inner terms are going to cancel each other out. Root 5 times negative root 3, root 5 times positive root 3. So then I can just focus on the lasts. Root 3 times negative root 3 is going to give me negative, since it's positive times a negative, and then root 3 times root 3 is just 3. And so then up on the top, I'm just going to leave it for now again as root 5 times root 5 minus root 3. So on the bottom, I can go ahead and subtract. 5 minus 3 is 2. I think we can probably tell that that's not going to be able to simplify with anything in the numerator, so I'm just going to go ahead and do my distributing. Root 5 times root 5 is 5. Root 5 times root 3 is root 15, and then it was minus up top, so it'll stay minus here. And so here, again, we've just changed our expression. It equals the same thing. If we were to enter this into our calculator, 5 minus the square root of 15, all of that divided by 2, it would be exactly the same as the original expression if we were to enter that into our calculator. It's just now we don't have a square root in the denominator, which is something that we're not allowed to have in what's considered a simplified expression. And that's true for all of the examples throughout these notes. We're not changing what the value of the expression is, we're just changing how it looks so that it doesn't have a radical in the denominator.